In this video, we will see how can we write a derivation of with respect to time as j omega and integration of time with respect to t and integration with respect to t as 1 by j omega. So we'll consider v of t is equal to vm cos of omega t plus phi. As we are interested in derivation, what I am doing is just I am performing d by dt of v of t. It is equal to Vm is the constant and cosine function derivative is minus the sine function sine of omega t plus phi, and inside for omega t the derivation is omega. Okay, then we can rewrite this one like this: minus Vm omega sine of omega t plus phi. Then I can write like this: minus, otherwise this minus I am removing, sine of omega, and it is sine of 180 plus theta I will take, because in order to remove this minus only I am taking 180 plus the rest of the angle I am taking. Now it is in the form of sine of 180 plus theta, that is equated to minus sine theta. So this minus I can remove by keeping this 180 plus angle. Then, but I need to convert this one into phasor domain, and phasor is applicable only for the cosine function. So I want to convert this sine function into cosine function. For that, Vm omega cosine of, what I will do, entire angle minus 90 I will take. Okay, so it is equal to Vm omega cosine of 90 plus omega t plus 5. So now it is in the form of cosine function. Now I can write this entire thing in the phasor domain. For that, what I will do is a real part of, I will take Vm omega e power j 90 and e power j omega t and e power j 5, like this I will take. Okay, so from e power j 90, what I will get is e power j 90. That means it is cos 90 plus j sin 90. Cos 90 is going to 0 and sin 90 is 1. 1 into j is j. Which means it is simply j. So j into Vm into omega and e power j omega t and e power j sin. When you are looking for phasor domain, we need to suppress the time. Okay, so what I will get is d by dt of v of t. Its phasor representation is simply I will take j vm omega and at an angle of phi, or vm j omega e power j phi, or vm j omega at an angle of phi. We know that for general v of t, the phasor representation is Vm at an angle of phi. But when you take d by dt of v of t, what did we get? The phasor representation is Vm into j omega extra we got. Because by comparing these two, we can tell for d by dt, the extra thing what we got in the phasor representation is j omega only. So the derivation with respect to time is leading to j omega in the phasor domain. So when you take this integration with respect to time, then what it will be needing, because it is a exactly opposite operation, here we have to take 1 by j omega. So simply you have to remember these two. One is when you take d by dt of d by dt, that will be leading to j omega, and when you take this integration of d by dt, that is leading to 1 by j omega. Thank you.